Good morning everybody, I am Subbu Ramanathan of grade 10 and I will be showing you my model today and explaining it. So the aim of my model is monitoring and control system using sound sensor to reduce noise level in public places. So the aim of doing this project is to design a prototype that would reduce noise level in public places. So you may all ask why I have choose this topic. So because you know that noise pollution causes so many problems like speech interference or something like hearing issues or something a lot about it. So when you see about noise pollution, the maximum range a person can hear is 85 decibels. So 85 decibels means it's the top most, and the minimum average one could be 60 decibels to 70 decibels. So if it exceeds 85 decibels, it could cause some ear damages or somebody to a normal human ear. So today I'll be explaining you what I have used in my model and why I have used it and what does it do. So let's start it. So first one is the ARDUINO UNO board. This one is the main unit of the whole functioning. So this one is like the heart. So this one inputs the program in it. So this one is the ARDUINO UNO cable and this one is the adapter. So I have to give a coding to it through a website called as ARDUINO IDE. So that needs to be installed in the computer and you have to code it. So this one is the sound sensor. The sound sensor is used for detecting sound. So I have given in that 60 to 70 decibels. So this one is the relay. So I have to pass the current from here to here, here to here, here to here. So the current is being passed to 3 areas over here. From the battery to the motor, from here to here, from here to here, and another source is connected from the computer to this one. So let me show you the working of this model. So actually, but before going into the model, you ensure that you do it with a 9-volt battery, because 9-volt battery makes you use simple for the school projects or something. But if you use in a large scale, you don't need a battery. You just need a power socket like this one. Actually, this is the main model. So they have used a plug. This one is the relay. This one is the ARDUINO board. That one is the sound sensor, and this one is the bulb. So instead of bulb, I have used the fan. Used a DC motor with fan, and instead of the plug, I have used the battery. So you may all ask, if it expands in the future, what can it be done instead of a computer? So this one can be given in 2 connections via this one. So come, I'll show you my model. So first, this one is the adapter. You have to connect it to this one. So you have to connect it to this one. So once after connecting this one, this adapter to this one, you can see that the fan is running. So once the fan is running because of the current produced in it. So later on the current won't be produced. So see, I'm clapping it now. So the fan turned on, and again I'm clapping it because of the fan's turning on. So since my I'm turning off to clapping my hands to turn it off. So since my hand is near the sound sensor, the fan turns off immediately. So if I go and do it in a long distance, like if I do like this, it detects, but only till 60 to 70 decibels is the average range, and if it exceeds 70 decibels or 85 decibels, the fan turns off immediately. So you may all have a doubt, how does it work? So this one works by, so actually if you are in a closed room and there are a lot of students with all like something like discussing something or doing something. So if you can't control or the situation, so this one, if the noise level exceeds above 85 decibels, the fans and lights turn off. So you may have experienced in your life that you are sitting in a room and the fans or light turn off, and you immediately notice something what's happening around you, and so henceforth you may all something calm down or do something or check around what it is. So this one, so I have to interlink between science and real life. So when both interlink together, you get this one formed. So this one is actually a clap sensor, but this one can be used as 2 methods. One is for controlling sound, and another is for lazy people who cannot go and turn on the switches of the fans or light. So if I'm so lazy and I'm just sitting like this and I need to turn on the fan, it just turns on and it just turns off. So I actually designed the prototype for one model, but it makes use in 2 models. So with this I conclude that reducing noise particularly in this is actually makes sense, but actually we need to maintain silence. So let me show you the conclusion. So I conclude that the noise level will be gradually reducing the certain areas where this one is used, and I ensure that this does actually make a change. Thank you.